Alright everyone, welcome back to week 2. This is going to be part B of our week 2. In this section, we will first do a really quick review of part A material. Then we're going to talk more about value returning functions, the return statement, and then at the very end, I will give you some debugging tips. Now these debugging tips, they're not specific to functions, but I thought this would be a good place to introduce these tips because now that we're writing code with functions in it, we need to start developing our debugging skills as well. So I'll give you a couple of debugging tips, and these will help you with whatever code you're writing, not just with functions. Alright, so first, really quick review. What is a function? A function is a collection of programming statements, it's just in particular for this class, Python code, that carries out a sort of subset of your program, carries out a specific task. More likely than not, your program will have many functions in it. One of them will be a main function that sort of controls the flow of the program, and then you might have other functions as well that sort of help out the program do smaller particular tasks. We talked very briefly about the difference between a void function and a value returning function. So a void function, like print, all it does is just runs the statements that's inside of it. That's it. The focus today will be value returning functions. So these functions are slightly more complex than void functions in that not only do they run the statements that it has, but they also create a new value, either through calculation, manipulation, something like that, and then it replaces itself with the value. It gives a value back to the program. Alright, so whenever I say a value returning function gives a value back to the program, what I really mean is when you make a function call to a function that is a value returning function, you can essentially think of that function call as whatever that value is. So again, when we think about functions, there's sort of two pieces to them. There's a function definition, which just defines what the function does, but it doesn't actually run code yet. And then the function call is what actually says, hey Python, you know that function I defined earlier? Go ahead and call it for me. So if at any point in your code you make a function call to a function, which is a value returning function, that function call is essentially a value, and that value is whatever value the function returns. Cool thing about this is the value that is returned can be used like any other value. So if it's a string, you can do string stuff with it. If it's a number, like an integer or a floating point value, you can do math calculations with it. So value returning functions, very powerful way to organize your code. Alright, really quick review. So int is one of those built-in functions in Python. Remember, this is the function that takes a value and converts it to an integer if it makes sense to be an integer. This is a value returning function because it produces a new value, basically whatever that integer is, and during the function call, it gives that value back. And then on the other hand, print is a void function. It just runs code, just displays stuff to the screen, so it doesn't really make sense to have print on the right hand side of an assignment statement. So again, an easy way to check and see if a function is a value returning function or a void function is to make a function call to that function, put that function call on the right hand side of an assignment statement. If it doesn't make sense, it's probably a void function. If it makes sense to be there, it's probably a value returning function. Alright, so today we will talk about writing our own value returning function. So yes, while int is a value returning function, it is a built-in one. So we are going to learn how to write our own value returning functions. Alright, so this is the general look of a value returning function. You'll notice it looks very similar to the functions we wrote on Tuesday, which were void functions. You still have the word def, you still have a name, you still have open close parentheses, you have the colon, you have everything indented into it. The main difference is this return statement. So a value returning function has a return statement. If a function has a return statement, it is a value returning function. Literally the only difference between a function definition that defines a function that is void or value returning is this return statement. So what this return statement does, this says, hey, return this value back to the program wherever the function call is. So it provides a value back to the part of the program that calls the function. So the way return works is you type the word return. This is one of those Python reserved keywords. And then after return, you type some expression. This expression can be a value, it can be a variable which has a value in it, or it can be some math expression that simplifies to a value, like a long math expression. Now, the value of whatever this expression is that special value that is being sent back to the part of the program where you make a function call to this function. Alright, so here's an example of a program with a value returning function. So looking at this program, there are two function definitions. There's one for main, and there's one for this function called do math. Cool. So main is a void function. There is no return statement in it. Do math, however, is a value returning function. I know that because one of the lines in it is return something. So when this code runs, Python reads, okay, main function definition, got it. Do math function definition, got it. Okay, call the main. So that very last line of code says, hey Python, go ahead and run the code that is inside main. So Python then looks up main. Main has two lines of code. First line of code is x equals do math 15. Alright, so this line of code, it's an assignment statement, right? X is a variable, equal sign, and then some stuff on the right hand side. But the stuff on the right hand side is a function call. So when we do this function call, there's a lot of sort of pieces that happen here. So let me go ahead and pull up our drawing board to make it a little bit easier to follow. So here's our drawing board. Inside main, we hit this line of code. X equals do math 15. This line of code right here. So what's happening here is we're inside this main scope, and Python wants us to create this variable x and put some value into it. Now the value that we're going to put into it is whatever value is returned from this function call. So let's go ahead and do this function call. So when I make this function call, right here, do math 15, there's a couple things that happens. We drop down here. Remember, this is an argument. This is a parameter variable. So if I go ahead and draw the scope for do math, when I make this function call right here, there's an assignment statement that happens sort of internally that says, hey, this variable num gets this value 15. So we'll go ahead and draw that. So this variable num gets the argument 15. Perfect. And then I return num plus 10. So num plus 10, what's that? That's 25, right? Because 15 plus 10, you get 25. So this is the return statement. It says return 25. So since this function call ended in code that said return 25, I can essentially think of this line of code right here, this x equals do math 15. It's basically saying, hey, set x to be 25. These two lines of code are essentially doing the exact same thing. So this x will now get this value 25. This do math 15, I can replace this with the value 25. And again, the reason why I do that on paper is because this do math returns a value. So the function call is essentially replaced with whatever value it returns. So then inside main, we have x now has 25 in it, and then we print x plus 1. So as you can see, that will display 26, because x is 25, add 1, you get 26 back. So again, the key takeaway here is this line of code right here. Whatever this expression is, you can replace this function call with that expression because of this return statement, because this is a value returning function. So I recommend you trying these two out by hand on your own. So same sort of idea, draw your variable box diagrams for each one of these two programs, then come on back and check your results. Go ahead and pause this video now and work on that. Alright, so for the first one here, you should have gotten 71. Alright, so let's talk about how you get that 71. So in this program, we have two function definitions, main and do math. Cool, and then we have a function called a main. Awesome. So in main, we have an assignment statement, z equals do math 4, 50. So this is a function call with two arguments now, right? 4 and 50. So when we make this function call, the parameter variable x gets the value 4, and the parameter variable y gets the value 50. So inside do math, x is 4 and y is 50, and we're going to return x squared, which is 16, right? 4 squared is 16, plus y, which is 50. 16 plus 50 is 66. So this return statement is saying return the number 66 to wherever you called this function do math. So that means up here in main, this assignment statement, z equals do math 4, 50, it's basically the same as saying z equals 66. So the variable z now has the value 66. So then when you print z plus 5, you'll get 71 displayed out on the screen. 66 plus 5. That's the first one. For the second one, you should get the number 1. For this one, I'm going to go ahead and draw all the variable box diagrams just because this one has a couple more lines of code. So let's go ahead and do that. Let me make a new file here. Alright, so again, we are stepping through this program here on the right hand side. So this program has 3 function definitions, main, func1, func2, then we have a call to main. Cool. We go to main, we run this first line of code here. So that's saying, hey, I'm in main, and I have this new variable a. Again, this is inside main, and I have this variable named a, and I got to figure out what to put into that a. Whatever I'm putting into a is whatever func1 gives us, right? A equals func1. Alright, so let's go to func1. Func1 says return 10 minus 5. 10 minus 5 is 5. So this is essentially 5, which means over here, I go ahead and put 5 into the variable a. Cool. That's this first line of code right here in main. Then we go to the second line of code in main. This one says we're going to make a new variable b, so let's go ahead and draw that. And then inside b, we're going to store the result of this. So just to sort of keep everything straight, I'm going to write that here. B equals func2a mod 4. Remember, this is the mod operator. Rewriting this, func2a, a is 5, right? Mod 4. So we need to figure out what this func2 5 is first, right? Alright, so let's go ahead and do that. Func2, and the argument is 5. So that means, over here in our sort of variable scope drawing diagram, I'll draw a new scope, and this is for func2. And the first variable that is assigned is the parameter variable num. And it gets the value 5, because that is the argument right here. Cool. So num is now 5, and then we return num plus 7, which is 12. So that means this part right here, this part right here, is 12. So now we have 12 mod 4. Alright, and remember the rule is with mod, it's the result of the division, the remainder of the division. So 4 goes into 12 evenly, right? 3 times 4 is 12, which means that division has remainder 0. So 12 mod 4, that gives us 0. Now I know it's been a bit, but the whole point of this is that we were trying to figure out what to put into this variable b. Now I know. I'm going to put 0 into b. Cool. That was this line of code. Then finally, we print b, which is 0, plus 1, which gives us this 1 here. If you do have any questions about this, feel free to post the discussion forum or send me an email.